So, hello, 大家好, and welcome to this talk, my first ever BSides conference talk, about arbitrary class loading on the JVM, arbitrary class loading on the JVM. Presented by yours truly. So besides being vertically challenged and moderately handsome, I do have a few personality traits. So about myself, I am a security researcher at Worley Labs, based in Cape Town. I have a lot of aliases, right? First and foremost would be Lord, Hicks Lord. I was a teenager, came up with it on a whim, I suppose. And then there's Kazamaster for my gaming ID, and most recently, Rootkit Zaddy. But if we're keeping it professional, then it's just Rootkit Ted. So just so that there's no funniness with business partners and all that. But yeah, I'm a hacker, exploit developer, reverse engineer at heart. Anything to do with memory corruption or C-based vulnerabilities, or any kind of exploit development that probably has my name on it. Get really passionate about that kind of stuff. I am 23 years old in age. I use the post-crement operator there because I'm turning 24 in a few days. And of course, if you hadn't noticed, I'm hoping it's evident, but I'm also a gym bro. Stay conscientious of my health and keeping it very cute, very demure. And so I'm also an anime enjoyer, right? Not really an otaku. I don't really watch as much lately. I'm a gamer. As you might have heard from the gamer tag, I'm mostly into Tekken, but I do play a lot of single-player games. And I am a man of culture. That is, I am in love with BMWs. If you're a Mercedes fan, I regret to inform you that this talk might not be the one for you. But so, we're not here to talk about me, essentially. Those are just the cliff notes. I hope I'm more than just the points that I was able to convey with this slide. We're here to talk about a vulnerability that was discovered on an assessment a couple years ago. More specifically, that one, CVE 2023-24824. Besides being a wonderful, very descriptive title for a slide, this refers to a vulnerability that we found in a Graylog's Graylog 2 server, or their implementation of their server. And it's essentially an arbitrary class loading vulnerability. Graylog were, just a shout out to them. They were really nice about this whole thing, and they know about the vulnerability. They've given us the okay to talk about it, and they have patched it. So, just a shout out to them for letting me actually talk about this. But so what the actual vulnerability pertained to was that there was a way for an authenticated user to essentially load an arbitrary class with if it had permission to change the cluster configuration of the Graylog server. And if you're not familiar with Graylog itself, they're like their software is essentially like for logging system events and a whole bunch of other stuff that I can't remember. But yeah, essentially they're a logging software, and yeah, well, let's get into it actually. So how we actually discovered the vulnerability was that we were on an assessment, and we're in the enumeration phase, right, which typically involves just like looking around the application, poking around. If I press this button, what does it do? Blah blah blah. And then we came across this particular request, right, and there was something funny about it, right? If you look at the exact endpoint, or the highlighted section of the screenshot, you'll notice that actually it looks a bit like a class, no? org.graylog2.users user configuration. So this was a bit weird, right? Why is there a class name in the endpoint that we're sending a request to? And so that made us look further into the code, and then we found the exact endpoint that controlled, or that dictated exactly what happens with that class. So key point here, there's a call to class for name, which essentially creates an object out of the class that we've just specified. And then there's a call to pass config object, right? Those two are very important for understanding the vulnerability. At this stage, we didn't know it was a vulnerability, so just bear with me. And so if you look at the implementation of parse config object, you'll find that there's a call to object mapper dot read value. And essentially what that does is it instantiates the class that we've just specified in the body of the endpoint, in the endpoint, the class that we defined there, it essentially goes and tries to instantiate that class with the body that we've provided in the request. So now we're like looking to understand the vulnerability, right? Like, so we need to understand what's possible with the vulnerability, like what can we do with this? What are any of the limitations that come with this vulnerability? And what are the requirements needed for successful exploitation of the vulnerability? And so in order to answer the first question, right, we look into how exactly the object mapper works, right? And so this is part of the Jackson databind library. And essentially there's a little example there that that I used to sort of gain a better understanding of how exactly Jackson databind works. And so what's happening there is that we have the object mapper variable, which stores a new object of type object mapper. And then we have a string, which is basically the JSON content that we're going to feed to the mapper. And then just, a fictitious class called person.class, but essentially it could just be a class with the two attributes name and age, right? So in this case, I use myself and my age as the details that I was going to feed to the object mapper. And what read value does is it's going to try and instantiate a class with those specific properties. Yeah, that's basically the gist of it. So read value takes two parameters, the actual JSON content and the class or the object value of the class that we're trying to instantiate, both of which we control based on the request that we just saw, right? So it basically comes down to this, right? Trade offer to the Graylog server. I receive arbitrary class loading. You receive a class name and a JSON object. Also, you have absolutely no say in the matter. But so we look at the limitations next, right? Can we just call runtime.getRuntime.exec? For the uninitiated, that's really just a way of saying, can we execute system commands, just like by abusing this vulnerability? And the answer is not quite, right? The problem is the class needs to be instantiable with the payload that we provide in the body of the request, right? That is, we can't directly go and invoke commands from different objects. And the other thing is that we need concrete object, right? Concrete objects. So that means no calling static functions, no calling constructors that are of an abstract object, right? We need them to be concrete objects with single argument constructors. Just another thing that I forgot to mention about Jackson is that when it actually creates the object, what happens is that you can either specify like a JSON object with the properties that you want that object to have, or you can specify, if it has a single argument constructor, you can specify the value that gets passed to that constructor for instantiation, right? So what that boils down to is we can't call runtime.getRuntimeExec because that doesn't have a constructor that has a single argument parameter, but you can do something like calling Java IO file, right? Because that is an object that takes a single parameter, in this case, a string that references a file on the system. In this case, I use etc password because, I was testing on a Linux machine, and that's, probably the one with which most hackers are familiar. So the nice thing about this is that since we can specify any class, right, that doesn't limit us to just the classes that are on the Graylog 2 server class path. So essentially, any standard library is also included here. So the scope has been broadened quite a bit. So, if we update it, trade offer, I get arbitrary class loading. You, as the Graylog server, receive a class name and a JSON object, and you kind of have a little bit of a say in the matter, given that we can't call any class or any object that exists within the class path. So now we need to understand exactly what's required to actually exploit this thing, right? So, of course, Graylog is a multi-platform piece of software. So, you could run it on Windows, you could run it on Linux, and there are a few discrepancies between the two. But the main thing for exploitation is that it needs to be of the Graylog server needs to be running on version 2 up to 5.2.3, within that range. If it's within that range, then it is susceptible to the vulnerabilities that we will, or rather the types of exploitation of this vulnerability that we will discuss later on. And then the other thing that you need is a user with sufficient permissions to actually edit cluster configurations on the server. Now, cluster configurations really just come down to, like a setting that you can change on the Graylog server. It's not too important to understand exactly how cluster configurations work here. So now we get into the actual part, the actual exploitation part of this, right? So the part that gets me the most giddy, because, it's kind of like my passion, I would say my life's work, but, I've only lived 23 years, so I guess it wouldn't really account to much. But so my best friend taught me this saying in Mandarin Chinese, 先苦后甘, which means bitterness before sweetness, but effectively it just means like, it comes down to, there's going to be a little bit of pain before we can actually reap the benefits of our rewards, right? So the way I went about exploiting this vulnerability, and the way it typically goes when it comes to exploitation as a whole, is that there's a ton of research that goes into it, right? Lots of trial and error, lots of trying things and failing, lots of pulling your hair out and discovering new words in different languages. Swear words, I mean, in different languages. Yeah, it's a lot of frustration, right? And eventually you get to a point where you understand the vulnerability so well that it almost feels like, you could describe the software to the people that designed it better than they can, kind of thing, right? So yeah, you get like a lot of research and a lot of frustration before you actually reap the benefits of your reward, the benefits of your efforts. And so the other thing I'd like to convey here is that for me, exploitation is kind of like kung fu, which is essentially just kung fu, but like how you actually say it. And so the way I think of it is that it's a nice little combination of art and science, right? A lot of it is methodical. A lot of it is like science-based. You have your hypothesis, your test case, your result, and you confirm that information. But at the same time, it requires a little bit of creativity, right? I think, obviously when you get to a point where, you're working with a vulnerability and you want to get to a point where you're trying to pop a shell, you're essentially solving for a problem that wasn't meant to be solved. And in so doing, you are in some way engaging in a form of art. But at the same time, that takes a lot of methodical approach and like a scientific formula in which you test something, you see the result, and then, you basically go from that, corroborate, triage, all that kind of stuff. But so yeah, this is essentially one of my favorite dark arts. Voodoo is reserved for Heritage Day. Yeah, so this is a very broad topic as well. There is a little bit of assumed knowledge, but I will try my best to make it accessible to everyone. Yeah, hopefully you like the illustration as well. I really do liken this to Kung Fu because I don't know if you guys have seen that movie with Jackie Chan and was it the Karate Kid, but like the one with Will Smith's kid. He says Kung Fu is in everything we do. I feel like exploitation is in everything we do. I'm not talking about like pre-1800s America kind of exploitation. I mean, this I like to think of it like it's okay. I feel like I can say this, But so when it comes to the arts of exploitation, I find that there's, generally we follow the same procedures, right? Now, this is in the context of a Java-based application. But I feel like if it were something, more, I want to say common when you think of exploitation, like memory corruption vulnerabilities, then, it's like it follows the same structure. You basically figure out like, okay, is there a base test case? In the case of memory corruption or like a buffer overflow, we first want to find out, okay, can I overflow the buffer, right? Can I overwrite the stack canary? Can I reach the return pointer? Kind of thing. Once you trigger that, you find out, okay, what can I overwrite the return pointer with? And so from there, it's really just like a series of questions that you ask to eventually get to a point where you can say, okay, I figured out all the moving parts. I have every single piece of the puzzle. Now I just need to put it together. And that's essentially what I tried to do here, right? The first thing is, can we trigger the vulnerability with a base test case? And then after we figure that out, are there any classes, or rather what classes are available to me to actually use in my exploitation? And then from that, could any of the classes that are available to me be used to do something interesting, do something that the server was actually not supposed to do? And then the last question, which you might argue should probably be first, is are there any existing Java exploit chains? The reason I put that last is because I'm a very try and reinvent the wheel kind of guy. And that is, I find that, if something exists already, like it's cool and stuff, but I don't think it should ever invalidate the efforts that one can make to sort of either, make an attempt at doing something and then learn something new. Perhaps it brings a perspective that you didn't previously consider, or you might find a new way to, sorry, I forgot to turn off my notifications, so I suppose we'll be reading my chats together. But so yeah, it might also bring into you might find a way to do something a little bit better than the previous or existing way to do it. So yeah, essentially that's what those are the questions that I wanted to answer, that I set out to answer when developing an exploit for this, right? So the first thing, triggering the vulnerability, base test case, right? This is essentially the flow of it, right? I mentioned before that we can call something like Java IO file with string parameter etc password. How this looks in the request is as follows, right? The first highlighted section is the class, as we've seen, and then the body contains the actual string that is passed to that object. So in this case, it's going to go, and then if you remember correctly from pass object, it's going to now map that object to that value, essentially call Java IO file with that string as a constructor, and then we should be able to get the contents back. Now, the result of this is that we were in fact able to read the contents of etc password. Given that this is a Linux machine, that would have worked. If it was Windows, you'd probably try something like, I don't know, something in the System32 folder or some such. But the point is, we're able to actually get the contents of that file, which is great. It's wonderful. But like, it doesn't make sense. I don't know. It just like, because we know that the vulnerability is really just an arbitrary class loading thing, but how does it actually go and retrieve the file, right? This might be what you're wondering. At least that's what I was wondering initially. And so it comes down to this, right? What we've done is that we've created an object of type Java IO file, right? We've given it a string, which is a path to an existing file in the system. And really all Java IO file is it's a file handler wrapper thing that has a reference to a file on the system, but it doesn't actually store the contents of that file, right? But then at the bottom there, you'll see that there's actually a, like what this controller does is that it creates, it calls the response.accepted, and then it passes the config object as a parameter to the request or the response that is returned. And so what happens is we have this strange interplay between Jackson data bind and Jersey response builder, wherein if you pass the Jersey response builder a Java IO file or like a file wrapper, it'll go and actually fetch the contents of that file and then return it in the response body. And so yeah, it's like this weird and beautiful interplay between the two. It's kind of unfortunate, but we have confirmed that the test case works, right? And so now we need to actually look for other classes that might aid us in exploitation of the vulnerability. So what I set out to do initially, or I think what everyone sets out to do, is just pop a shell. But in this case, I would want to, get like a reverse shell going kind of thing, right? And so in order to do that, we need to get all of the classes. We need to understand, is that actually possible? What classes can we call that have the requirements of exactly one argument in the constructor and that has like some kind of side effect, right? So there's a tool to do this that I used called Yearn, right? And it was developed by the beautiful man in the background. Sorry if we're reading my chats, like I said, but it was his invention essentially. And yeah, it's Yearn, which is just an open source tool for static code analysis, which was designed with the purpose of, or for the purpose of vulnerability research. It is basically like it combines a bunch of graphs that are generated from a code base, right? So a whole bunch of different graphs, namely the abstract syntax tree, which is like based on what the code looks like. And then there's the control flow graph, which specifies like how the program gets from one point to another in the code. And then there's the program dependence graph, which just defines how each part of the code interacts with each other, essentially like what you need to get from point A to point B kind of thing. And so this was, sorry, just another thing, it supports a lot of languages. So, if you want to use Yearn on like a C code base or a Java code base or Python or Kotlin, it has support for multiple languages. But so all of those graphs are combined into one, which is known as the CPG. And essentially you can query the CPG that is generated from a specific code base to gather insights into the code and how it works, right? So in this case, this is the query that I ran. And essentially, we're just looking for, so like if you're using a jar, you'll find that all constructors really just conform to the format of init, right? And so from there, we look for all of the ones that have exactly one parameter. And then I ended up saving it to a file. But that's still a lot of entries, right? That's around 2,000 entries that we need to look through. And the truth is, ain't nobody got time for that. So what I did was I went and I refined the query, narrowed it down, and I kind of refined the criteria a little bit, right? What we're really interested in is a constructor that has some kind of side effect. Ideally, like the absolute silver bullet would have been any constructors that have an implicit or explicit call to runtime, get runtime exec, or process builder, or something that actually starts a process on the target machine. Or if that's not possible, which, let's be honest, that is a bit of a long shot, right? There's no constructor that I know of that actually does that. But, there's still a possibility it exists, so we search for it. But, anything else that creates like an outbound connection to it creates an outbound connection to an attacker-controlled server, or that writes data to the disk. Because let's be honest, if you have like an arbitrary file write or write what where, then RCE is like almost guaranteed at that point. Or something that opens up the application to other attack vectors like cross-site scripting, XXE, local file inclusion, etc. Right? Buffer overflows are included. Also, it's very unlikely, but it's still definitely a thing that you should look out for. So after refining the urine queries, we got to a point where it's the number of entries that we have to look for, that we have to look through, is in the low hundreds. Right? This is acceptable. This pleases the nut, where I am an element of. Then you get the point. Okay, so now we actually get into a point where, just for context, after having found all of these classes, this part involved a rigorous sort of trial and error stage of like trying to, it's back and forth looking at like a class that was specified or returned by the urn query and the source code that's involved in it. And then like, trying to see if I can trigger something interesting. And so really I'm about to show you like the highlights, and then we'll like increase the intensity and level of neatness as we proceed through the rest of the talk. But so the first of which is the file alteration observer, right? I hadn't ever worked with this until I, found this in the results that Jörn returned. But essentially what it would do is that you'd give it a directory, and then it would scan all the files and directories or subdirectories within that directory. And then, so it's supposed to essentially just like alert you if there's a change, right? This probably wasn't going to work, but what it does do is that, one, it takes a single parameter. Good, you like this. Two, it returns the full absolute path to the directory that you specify. So if you just put a period, i.e. current directory, it'll show you where in the Graylog server you are, right? So this is what it looks like in action. I have blurred that out, but really it's just rootkit daddy. I didn't know if you guys would be comfortable with seeing my rootkit daddy just reflecting over there, but you guys have context now, so I feel like it's okay to say. But so, yeah, right over there, you can see I've specified file alteration observer with the current directory as the body of the request. And so as a response, we get the full path to where we are on the Graylog server. This is cool, right? We have a little bit of enumeration going on, just like some light info leakage, but let's take it further, right? So another thing that I discovered was that there was actually a class or a piece of code. This was done with manual inspection, because at some point you just look like, hey, is there something that just calls process builder or runtime.get runtime exec? And so this was one of them, right? This would have been super helpful. Essentially what you notice is that there's a method called sh, which, as you might have guessed, opens up a shell, takes a command that you've specified and then just executes it and then shows you the result. That would have been perfect. That literally would have been like, it would have halved the development time or the exploit development time. The problem is that it didn't have any constructors that we could invoke. No single parameter constructors, and they're all static essentially. So yeah, that was kind of disappointing. But we move, we take the hits, we keep running. And so we get to the next thing that I discovered that was really cool. The Linux OS processes object from the Oshi software package. I'm not going to say the whole thing, but yes, you get the point. So this one was a lot more interesting, right? It basically just represents an entire Linux process. I'm not sure if there's a Windows equivalent. I never really looked into it. But essentially, again, it meets the requirement of one parameter. And the other thing is that it gives a lot of details about the process on the Linux machine, right? Things like PID, CPU usage, the exact command line used to actually start the process. And all it takes is an integer value, right? So there's a little bit of guesswork unless you're familiar with the process ID space that a specific system uses. But the nice thing is that if there's rate limiting, or rather a lack of rate limiting, then you can essentially just spam all the processes from 1 up to whatever number makes you feel happy. And essentially you'll get all of these details like as seen in the example slide. So yeah, in this case, you can see the exact command line that was used to start the Graylog server. Context, that PID belongs to the process in which the Graylog server was running. And so, yeah, there's a lot of details there. The group ID, the user who started it, the exact command line. This is cool. This is cool. We're getting a little bit more interesting output, right? And so, yeah, I mean, it's another process enumeration type, or rather, it's another enumeration type of usage of this primitive. But wait, there is more, right? The next thing is Java Assist Tools web server, right? This is just a simple HTTP server that serves Java class files, and it takes another single integer argument, right? So you might be thinking, or at least what I was thinking at the time, is this kind of seems like it's leading up to a point where we can pull files off the server, which is like, it's cool, but we can already do that, right? The first base test case kind of allows us to do that kind of thing exactly. So what would be the point of this? But then we take a look at the responses from the server, right? If you specify a port, 8084 in this case, and then send the request, the server responds with a 202, accepted, and then it returns some JSON data that honestly isn't that useful to us, right? But then, you can also confirm that we've started up a listener, or it actually bound to the port at the very least. Because if you look at the screenshot, that's before, the first one is the output of nmap before the request is sent, and then later on is what happens after. So we know that it is actually binding to the port. But then you take a look at the response if you specify a port that's already in use. Port 9000 is already in use. So in this case, it responds with a 403. I think, yeah, 403, and a little error that says, okay, well, there was a problem doing this or whatever. But what does it mean, right? We get characteristic responses based on the port, we're based on whether or not the port is actually available for binding. And so what this means is that we get like a bootleg, kind of ugly, slightly noisy port scanner. And the nice thing about this port scanner in detail is that, like, it won't just specify open ports that are accessible to everyone on the network. This also includes localhost ports. So oftentimes you'll find like MySQL or something running like on localhost, only accessible by the same machine. This will give us information about that, all without having to send a single TCP packet to any of the other ports except port 9000. So I mean, I think that was pretty good. It's a nice win. And so there was another primitive that actually opened up the application to XXE vulnerabilities. And that was in the validator resources object. And essentially what it did was you could specify a URL, which, because validator resources expects a path or a URL to an XML file, right? And what it does is if you specify URL, it'll go to that server, pull the file, and then try and parse the XML. But the thing is, by default, it doesn't incorporate any of the existing default XML protection mechanisms. So in this case, if you specify an attacker-controlled server, hi, I'm attacker, and then you specify a file at that server, what you can do is now effectively, have the application be open to XML or XML-based attacks. So in this case, this was just me testing to see, like, hey, is this thing actually going to try and fetch? And I noticed that it did. And so what happened was I built this little exploit, or not, you can call it an exploit, but really I just configured these two files, the XML file, which in turn calls a DDT file, and the DDT file tries to read from the proxys kernel hostname, which essentially is just the hostname of the system. This is a proof of concept, so I didn't get too gnarly with it. And so I started up an HTTP server on port 4443, and you can see that actually it went ahead and read the contents of that file. Now again, we already have a primitive where we can read from the file and essentially read from any file depending on the permissions of the user who started the Graylog application. But this is still just a nice thing to have. And essentially, if you want to go the loud and dumb route, you could also use like a DOS attack against the application, because the billion laughs attack is still a thing. So if you want to be gnarly and sort of have the application or the server stop responding for a minute or two or three or however long you want to keep the DDoS going or the DOS going, then you can go ahead and exploit it that way. So yeah, there were a bunch of other primitives that came with this. The histogram log writer is essentially an object that let us write any file to the system. Again, restricted by the permissions of the user who started the Graylog service. But we couldn't really specify what to write. So it's really just like a write where, but not a write what where. It can be useful if certain programs depend on the existence of certain files. But in this case, like with the default setup, it wasn't quite a thing. And then there were a few SSRF potential objects. Essentially, they just send out GET requests, much like the validator resources object. But nothing too crazy there. Essentially, you could just make the server send a request. It's cool stuff, but not really like the real stuff. It's not what we're after at this point. So what about RCE? That's the real question, right? Like, can we pop the server using this method of exploitation? And unfortunately, it just got to a point where I was looking through these things and I didn't find a single one that had a process builder or just some form of command execution. And I looked for exploit chains and I still couldn't find anything, right? The existing ones required packages that weren't included in the Graylog server package list. So, it was a bit difficult at this stage. And so I ended up feeling like this. It was tough. It was tough days. I was really thinking, you know what? I think I'll just present this stuff and then call it a day. Yeah, it was a very difficult time in my life. But so I got to a point where I'm like, wait, hang on. Let's go back to the implementation of Jersey Databine's object instantiation technique, right? So essentially it came down to none of the constructors have what I needed, but Jackson Databind does in fact call certain getters implicitly and certain setters implicitly, depending on how you actually create the object, right? So remember before, in all those instances where we got a JSON object that detailed the attributes of an object that we just instantiated, in some of those, the getters and setters were invoked implicitly, right? So essentially what I did was I started including getters in the in my search for classes that could be used to achieve RCE. And what I ended up finding was this class, right? It seems pretty useless at first, right? It does take a single parameter in one of its constructors, and all it does is it just sets the printer name, right? The Unix print service class, that is. And so it's like, it seems pretty useless, but then you get to a point where you're looking at this getter. Get printer is accepting jobs BSD, right? So it's Linux specific, yes. And so the thing that drew my attention there was that there's a string variable called command. Seems awfully suspicious. And it invokes LPC status and then, just sort of plugs printer right in there. And I was like, oh, wow, look at that. It's plugging printer right in there. And I'm like, wait, it's plugging printer, which I control, right in there. And so immediately after that, it does an exec_cmd. And so after looking into that, you can see that really it's just invoking a shell command to do this. And so we exploit like so. And so what it ended up doing was I just invoked PHP, but really you can get like a ton of other payloads that you can use to get a shell. Rev shells is a thing. And so, yeah, this PHP payload worked for me. And so we get to a point where, we're at the demo. Now, it does pain me horribly to let you know that I will not be sacrificing any chickens for the demo today, especially as a black man. You know how we love chicken. I have instead prepared a demo that we will watch. It's uploaded to my YouTube, but it's private, so like and subscribe either way. So the first thing that happens is I check the version of Java and start the Graylog machine. And so, as you can see, the Graylog server is up and running. And then next up, I just test the connection to make sure that it is in fact running and is reachable. Don't actually log in. Don't want you guys to see my really secure passwords. And so this is the exploit I wrote for it. I will be posting this at some point later in future. I'll be uploading this to my GitHub at some point in future once I have a go ahead. But yeah, this is just like some an introduction to the things that the exploit does. Really just like doing the login, getting the authentication token, checking if the Graylog server is in the vulnerable range, actually sending the payload. Yeah, this is all configurable with the arguments that the exploit takes. And yeah, some quality of life stuff, arg parser for the win. And then we get to the VM. I decided to run the exploit from my Windows VM because this needs to be on a Linux system. So, you know, over there you can see the arguments that the exploit takes. And yeah, and essentially the command that's used to invoke the exploit. So as you can see, it tries to authenticate, gathers the information it requires, sends the payload, and then eventually, boom, we have shell. Yeah. So just a quick thing about this exploit. This on later versions of the Graylog 2 server, Java 8 is no longer compatible, right? So you need to use Java 9, and so that might, if you end up running this exploit there, you'll see in the error logs of that of the later version of Graylog that you choose to use, you'll see something like, oh, unable to make whatever accessible to whatever because it does not opens, blah, 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 right? And that is a result of the JPMS, or the full name, I can never remember this thing, Java Platform Module System, right? That was introduced in Java 9 onwards. So essentially, the RCE vector of this thing will be eliminated if you try and run this on like anything Java 5 point, or rather, over, I was using like Java 4 point something for the actual exploit, but yeah, so the versions of Java that require Java 9 and above won't be susceptible to this kind of thing, and yeah, so really that meme kind of sums it up, right? You shall not pass, lil bro. But so it only eliminates the RCE vector, but like, for one, the thing to consider, there's still a surprising amount of systems out in the wild that are running legacy software or legacy code. Some still probably running like this exact version of Graylog, which, yeah, it's just not a good idea. You should always keep your software up to date. But the other primitives or the other methods of exploitation are still very much doable, right? The bootleg port scanner, the uncontrolled file write, the pulling of arbitrary files on the system, again, restricted by the permissions of the user that started the process. That's all still very much doable, right? Up to versions 5.2.3. But so yeah, that pretty much concludes the talk. Essentially, just keep your software updated. Source, dude, I literally just showed you my exploit. But so yeah, I mean, I'm opening the floor up now for questions if there are any. Yeah, ask away if there are any questions. No questions? Sorry, I did have one more slide after that. I don't want to. Okay. All right. Yeah. So it's just a little self-plug. If you're, I did mention I'm a gamer before, so thank you for coming to my talk. Yeah, I'll post the source code on my GitHub. Link is over there if you want to check it out. I'm Ted Thobane on LinkedIn, so let's connect. And yeah, 谢谢大家.
Rootkit Zari. I just have a question. So you say you're going to post the code onto GitHub. Did you use your own offline lab to do this in?
Yeah, very
Would
much.
you also be able to post that as well, so we have something to test against?
Yeah, I believe so. I mean, it's open source, right? So literally everything that I used, you can just like.
Okay, as long as the configs are there, and I don't have to like message you and be like, "Hey, Teddy."
Yeah, no.
I don't know how to Google.
Yeah.
Okay, cool, man. I love the talk and I love the name.
Oh, thank you so much. I worked hard for it. Just another disclaimer, a little humble brag. I did not use ChatGPT at all for the exploit. Thank you.